Okay, so yeah, welcome to this video again. So I'll be doing question 2. So we proceed from where we ended. So yeah, we got question 2. So question 2 is saying Kapasa Makasa University has a satellite campus in Kasama and Mbika. The main campus has 62 hosts, and then Mbika campus has 21 hosts, and Kasama campus has 33. And the three campuses are connected through a one links, meaning we'll be using serial links for a wide area network. Then use VOCM to subnet the IP address which is given. So it's a class C IP address with its default subnet mask. Each campus has 2 hosts belonging to accounts. So the first thing we're going to do is we are going to start subnetting. So we are given the IP address which is 192.168.20.0 with its default subnet mask which is 255.55.55.0 or a /24. So under question 1 we did subnetting and I explained a lot of things. So on this one I'll be just going direct to the point. So since we're using VSM subnet, we're going to come up with a variable length subnet mask table. So we'll say a VSM table. So under the VSM table, start with the block size, and then the class race interdomain routing and the subnet mask. Okay. So a block size will start at 1. Then for the CIDR will start at 32. Then the subnet mask is 255.55.255.255. So yeah, here because if we convert 255 into binary we get 8 ones. Then if we convert again these 8 ones, so if we have 4 255s, it means we have 4 8 ones. So 4 times 8, which is 32 ones in a network for CIDR. So when coming up with the block size, we're saying times 2. And then for the CIDR, I'll be saying minus 1. Okay. Now we can proceed. So 1 times 2, we are getting 2. And then 32 minus 1, which is 31. And then for the subnet mask, since it's a class C, this portion won't be changing. Then this host portion will be changing. So the network portion doesn't change, the host portion changes. So to come up with the subnet mask, we'll be saying this number which is changing 255 minus 1, which is the block size, we are getting 254. Okay. So again we'll say and the block size is 2, so 2 times 2, which is 4. 31 minus 1, which is 13. And then for the subnet mask, we continue 254 minus 2, which is 252. And then 4 times 2, which is 8. By now we know the pattern. So 30 minus 1, which is 29. And then 252 minus 4, which is 248. 8 times 2, which is 16. 29 minus 1, which is 28. And then okay, just a little bit. So here we had this. So 252 minus 4, which was 248. Okay. So 8 times 2, which is 16. 29 minus 1, which is 28. And then in the mask, we'll say 48 minus 8, which is 240. 16 times 2, which is 32. 28 minus 1, 27. And then the mask, 240 minus 16, which is 224. And then we have 32 times 2, which is 64. 27 minus 1, 26. And then in the mask we have 224 minus 32, which is 192. 64 times 2, which is 128. 26 minus 1, which is 25. And in the mask we have 192. So 192 minus 64, which is 128. And then when you reach 128 under the block size, just put a 0. And then 25 minus 1, which is 24. And then the mask we have 128 minus 128, which is a 0. So based on the question you are given, this is the initial requirement for a class C. So the default mask has a .0, the slash is /24, as you can see according to the question. So it's a .0 but /24. Okay. Now that we have a very same table, let's consider the question which has to do with Kapasa Makasa University. So say Kapasa Makasa University. Okay. So under Kapasa Makasa University we have Kasama, then Mpika campus. So apart from that we have the main campus. So let's say we have the main campus, then we have the Kasama campus, then we have Mpika campus. Okay. So the main campus, they are saying it has 62 hosts or devices. So since it has 62, we'll just put 62. And then Mpika campus has 21. Okay. So Kasama campus has 33. So Kasama has 33. And then Mpika has 21. So these are just number of hosts. Okay. So based on these requirements, we can start making decisions. So what block size can accommodate 62 hosts? In our case, we can see is 64, because when we subtract the network and broadcast address, we still get these 62 devices which can be assigned. So we say block size, so we've identified as 64. Then the number of hosts which can be accommodated, so 64 minus 2, so we are getting 62 hosts. These are the hosts we want. So what's the subnet mask? So the subnet mask, as we can see, the block size which has a 64, its mask is 192. So we are going to get that like that. So now we can come up with the IP address range. So since this is when we are starting to subnet, so take note, under VSM we start subnetting the bigger network. So this is the bigger network followed by this and then that. So since this is when we are starting to subnet, we'll get the IP address which was given from the ISP, Internet Service Provider, which is the starting point, which has a .0. Then we're going to say 64 plus 0, because this portion will be changing, most portion. So we'll get 64. But because we need to maintain the broadcast address, we'll be saying -1, so we'll be getting 63. So to explain this, we say if this is an IP address, network address, and this is the broadcast address, which is 63. Remember, we said to get the number of hosts, which is 62, we subtracted the network address and the broadcast address from that block size to get 62. So 64 minus 2 was 62. So to confirm that, we can say this is an IP address, so we consider it as 1. Then we have other 63 IP addresses. So if 63 minus 1 are getting 62, it means the range is correct. Okay. So from that, we can come up with the default gateway, which will be used to be inserted into our router to deliver packets. So since we cannot assign the network address or the broadcast address to a device, we can start at .1 for the default gateways. Okay, and then the devices will be following now. So I'll copy this information and then we'll paste it under Kasama campus. So Kasama campus has oh, by the way, 62 hosts, it was under slash 26, as you can see. So here I need just to indicate that it's a slash 26. So how many hosts can be accommodated now if we're considering 33? So what block size can accommodate 33? Again, since 32 cannot accommodate, to go where there's 64. So the requirements will be the same. 64 can accommodate 33 because the valid number of IP addresses are 62. So the mask will be the same again, but we ended at 63. So we are going to start at 64 as our network address. So we'll say, where can we end? Okay, so 64 plus 64, we are getting 128, but we'll say 127 to maintain the broadcast address. So this is the network address and this is the broadcast address. So we can put the default gateway as 66. Then within this range, we can assign now devices which fall under this. Okay. So now going to the picker campus, we'll say since, okay, so again this was a slash 26. So since we need 21 hosts for this one, we know that 32 can accommodate 21. So the block size for this one will be 32. Then it's slash 27 to 24, that's the mask. So we'll say the block size is 32. So the host which can be accommodated 32 minus 2, which is 30, and it can accommodate 31 or 21. Then we are saying the mask is 224. Then since we ended at 127, we are going to start at 128. So 32 plus 128, I'm sure it's 224. So let me just confirm. So we are saying 128 plus 32. Oh, it's 160. So 160. So we say minus 1 to have 159 to maintain the broadcast address. So after doing that now, we'll change the default gateway to 129 because after the network address we can have this IP address. Okay. Since now we are done subnetting, we can use these requirements to come up with our topology, something which looks like this. So for this video I've already created one, so we'll just do this. Okay, so here's the thing. So this is representing the main campus, and then this is representing Kasama campus, and then this is representing Mpika campus. So these four under Kapasa Makasa University. So as we can see from the question, it was saying uh, the three campuses are connected through a wide area network links. So we are using serial links because these are the connections for a wide area network. So that was the first requirement. And then the next one, it was saying each campus has two hosts belonging to accounts. So as you can see, the main campus has two PCs belonging under accounts. Then again, two under Kasama campus to belong under accounts. Then Pika campus, we have this and this to belong under accounts department. So two hosts for each campus to belong under accounts. So the next thing we're going to do is to use OSPF to enable intercommunication. Then we need to perform port security to a switch port where the account server is connected so that no other account can connect. Okay, so since this question talks about account server, so since this is the main campus, I've decided to put the account server where there is the main campus as shown. So now this was all about the requirements. We can now see how we can assign IP addresses to these particular devices on a network. Okay, so since the requirements are like that, we are going first to say let's continue subnetting because we have three routers. Okay, so I'm going to say routers. So for routers, we know that we can treat them as two hosts each. So based on that, what block size can accommodate two hosts? So is 4, because when you say -2 for the network and broadcast address, we are remaining with it 2 hosts. So 4 minus 2 is 2. So it's a /30, then 252. That's the mask. So we're going to say the block size is 4. Then the number of hosts which can be accommodated. Okay, so we say 2. Then the subnet mask, so we are saying is 255.255.255.252, which is a /30. Okay, now so we have devices. So under devices we have router 0. So we say router 0. Okay, and then we also have router 1. So we say Andy router 1. So if you are trying to treat router 0 and 1 as two hosts, we are going to put the IP address range. IP address range. Okay, so since when subnetting we ended at this point, which was 159, so we are going to continue where we ended from 159. We just say 160. Okay, 160. So now if we add 4 plus 160, we get 164, but we say 163 to maintain the block size. So we'll give an IP address to router 0, which will be after this network address. So we are going to say 61. Then we'll give router 1 the IP address just before this broadcast address, which is 62. And then we can continue now with the other devices. So now we treat router 0 and router 2 as 2 hosts. So I'll copy this and then now say router 0 and router 2. So since we ended at 63, we're going to start at 64. So now we'll say 4 plus 164, which is 168, but to say 167 to maintain the broadcast. So router 0 after the network address can be given an IP address which is 165, then router 2 166 before we reach the broadcast address. So again we continue. So here I'm going to treat router 1 and router 2 as two hosts, then we are done. So I'll say 1, then router 2. So since we ended at 167, we're going to start at 168. And then we'll say 4 plus 168, so which is 172, but we just say 171 to maintain the broadcast. So after the network address, we are going to put 169 to represent router 1, and then 170 to represent router 2. Okay, so let me just go back up. So the main campus has devices. So I'll say devices. So under the devices, we can see we have PC1. So say PC1. So PC1 can be assigned an IP address after the default gateway, which can be .2. Then we can see we have PC2. So I'll say PC2. Then we're going to assign it .3. Then we have the server. So the server we are going to assign it .4. Then lastly we have the laptop. So say laptop 0, which will be going which we assign it .5. So now we go under Kasama campus. So under Kasama campus we also have devices. So the first device is PC3, and the last device or the next device is PC4, followed by laptop 1. Okay, but we don't have a server. So since the default gateway was 67, this PC can have 60 or 67 since we had 66, then followed by 68, and then 69. Now we go under the last campus, which is Mpika campus. So for Mpika campus, we have PC5 and PC6. So PC5 and PC6. So since the default gateway was 129, this can be 130, then this can be 131. So we also have a laptop, which is laptop 2. So laptop 2 will be 132. Okay, now that we are done making a decision of the IP addresses, we just need to start assigning. So under main campus, we start with PC1. So as we can see, the mask is 192, so keep that in mind, and the default gateway is .1. So we assign PC1. So we assign it with this IP address which is given. We are saying the mask is 192 and the default gateway is .1. Okay, we go to PC2, which has this IP address, and then still under the same network. So we give it that IP address, we say 192, then .1 for the default gateway. Then we go to the server, So the server under desktop, then IP configuration, we are using static because we are doing it manually. So we say 192 and then .1, and then we finally go to the laptop under the Chishala main campus, and then assign that particular IP. We say 192.1 for the default gateway, then we are done. Now we are going to go under Kapasa campus. So PC3 is given this IP address, but take note that the default gateway is 66, then the mask is still the same, which is 192. So this is PC3. We are going to use the given IP. We're saying the mask is still 192, but default gateway is 66. Okay. And then we go to PC4. So PC4, we give it the IP address, which is that. And then here we are still using .192, then 66, which is the default gateway. And then last three, we go to laptop 1. So laptop 1, we are saying we have this, then we say 192 and then .66. Okay, then the last campus, which is Mpika campus, the first PC5, we have 130, but the subnet mask is 224, then 129 for the default gateway. So we start to assign that, then we say 224, then 129, and that's the default gateway. We go to PC6. So PC6, okay, so in laptop 6, now I'll paste the IP address, and then we'll say 224, and then 129 for the default gateway. Now since these devices are configured with IP addresses, we just need to make sure that their interfaces connecting to the router is on, so that we can enable packets to be sent over the network. So we'll start off with the main campus. So under the main campus, we'll use this default gateway to insert it into the router connected to the main campus. So the main campus in this interface I was using is FA1/0. So under config, we'll go where there's first Ethernet 1/0, which is connecting to the main campus. Then we paste that. Then that default subnet mask is 192. So we're going to say 192, and then we're going to say on for the interface to be on, like that. So we go to Kapasa campus. So get the default gateway for Kapasa campus, and then their mask is 192. We insert it to the router which is connected to Kapasa campus. So again, the interface which was used is 1/0, and then we're going to say 192, then on, for that particular interface to be up and running. So the last campus, which is Mpika campus, we get the default gateway, and then we make sure that we insert it to the router connecting the Mpika campus. So the interface again is this, and then we're going to say 222. So we are going to say 222 for the subnet mask. So I'll say 222, then on. So now at least these interfaces are okay. I just need to turn on the routers. So remember we subnetted for the routers. We are going to say between router 0 and 1, router 0 is given this IP address between these two. I've connected these two under the port which is serial 2/0. So under the serial 2/0, I'll paste that IP address. Then for the routers, we are saying 252, that's the mask. So I'll change it to 252, then on. Okay, then I'll need to get the mask, the IP address for router 1 connecting to 0. Again, we'll use that same interface because that's the way I've connected them. And then we'll say 252 on. It means that interface will be up like that. So now we are going to get this IP address for router 0 between 0 and 2. 0 and 2. So I've connected this under serial 3/0. So under serial 3/0, I'm going to paste. Then we'll say 252 and on. And then for router 2, this is the IP. So remember the interface is 3/0. So I'm going to paste. And then we need to change it to 252 for the routers. So now the interface is up. So the last connection is between 1 and 2. So where there is 1, I've used 3. So here I'll go under serial 3 and then 252 on, and then to connect it to router 2, here I've used serial 2. So that will be based on the way you are assigning the ports. So since this topology was already made, I know the connections, but you can use these ones if you want to follow along. So now that everything is up, let's try to test out something. So the IP address for PC2 is .3. So let's try to see if PC1 can communicate with PC3, which has an IP address which is .3. So since they're under the same network, they'll communicate like that. So it's okay. Now imagine, so it means so far whatever I've configured under the same network, they can communicate. So I don't need to confirm from everywhere. So what if we want to communicate with this account device which has .67 from car? So I'm saying, what if main campus wants to communicate with customer campus? Is it possible? So since that is .67, I'll just say .67. So as you can see, it's saying destination host unreachable. So this is because we haven't configured the routing protocol, or maybe it's not configured well. But in this case, we know we haven't inserted any routing protocol. So once more, let's try to see if main campus can communicate with Mpika campus. So I'll choose this device which is .130. So I'll try to ping .130 now. So again, destination host unreachable because we haven't configured routing protocols. Now coming back to the question, it was saying use OSPF routing to enable intercommunication. So this is when we are starting to answer the question. So now let's talk about OSPF. So that's question 1 like that. Okay. So commands for open shortest path first, OSPF. So what OSPF does is that it's a routing protocol which will deliver a packet to the destination using the shortest path or route. So in this case, if this device wants to communicate with maybe this device, instead of taking this route, which is the longest route to communicate with that device, is going to take this route, which is the shortest path to communicate with that device. So that's what OSPF does. So OSPF is configured in a router. So here we are going to first start off with router 0. So under router 0, under command line interface, we're going to say en conft. So en to go from the user mode to the privileged mode, then conft, which is configure terminal, to go from the privileged mode to the global configuration mode, where we can configure something. So here we're trying to configure OSPF. We say router OSPF, which is the protocol. So we can select a particular number from 1 up to somewhere. So I'll say OSPF 1. Then we need to broadcast the networks we are connected to. So in this case, router 0 is connected to Chishala main campus. So we need to get the the network address for the main campus, which is .0. Then we need to take note of the block size. So the block size is 64. So we are going to say the network is this. Then we need to insert the broadcast bit, which is, since this portion won't be changing for class C, we replace it by zeros, 0.0.0. Then the last portion, which is this, which will be changing, we're going to put the broadcast address, so it will be known from the block size. So since the block size is 64, we say -1 to maintain the broadcast. So this is the broadcast bit for this particular network. After that, we say area, we put this command in a certain area, for example area 0. Then we've broadcasted that particular network, which is the main campus. So again, router 0 is connected to router 1 and router 2. So we have 2 networks to go. So I will say 1, then 2. Now remember, when subnetting these two the routers, the block size was 4, but their outcast bit, if we subtract 1, supposed to be 3. So since this connection is under routers, we are going to put 3. Instead, we are not using that block size, the previous one. So since we are targeting router 0, and router 0 as this network, so between 0 and 1, we have .skiste. So the first network is .skiste. Then between router 0 and 2, we have 164 as the network. So 164. So we are done broadcasting all the networks. Now we'll say end, then WR to save the configurations. So after doing this, we're going to continue. We target router 1 now. So remember, router 1 is connected to Kapasa campus. So I'll go where there's Kapasa campus. So Kapasa campus has the network, which is .64. Then the block size is still 64. So I'll say the network address is .64. Since the block size is 64, we'll leave it at 63 after we subtract 1, which is okay. Now router 1 is connected to router 0 and 2. So since we are saying we are targeting router 1, we can see between 0 and 1 we have 1 skiste, and between 1 and 2 we have 168. So we are going to use this information for the routers. So 1 skiste, then 168, like that. Okay, so we are done for router 1. Then lastly, we are going to target router 2. So router 2 is connected to Mpika campus. So go ahead, is Mpika campus. So Mpika campus, the network address is 128. Then the block size is 32. Take note of that. So we're saying network address is 128. Then the block size, since it's 32, say minus 1 to have 31. Then router 2 is connected to router 0 and 1. So let's check that. So between 0 and 2 we have 164. Then between 1 and 2 we have 168. So let's consider that. So we have 168 and then 164. So now we are done. So we have 164, 168, correct. So we are going to paste these commands into the routers. So this is for router 0. I'll go under router 0. Then I'm going to paste these commands. So exit this, we start afresh, and then we're going to paste those commands. So we are done configuring OSPF in router 0. So we come to router 1. So under router 1, we paste these commands. So we exit this mode. Okay. Then we paste. And then the last configuration is for router 2. So under router 2, we exit this mode. Then we paste. Now, since OSPF has been configured, let's see if Chinsari main campus can communicate with the Kasama and the Mpika campus. So go back to this device, then we'll see if we can communicate with those particular devices we were trying to communicate with. So as we can see, we can now communicate with .30, which is from the Mpika campus. Then we had .67, which was for the Kasama campus. So let's see if we can communicate with that. So again, as you can see, we can communicate with .67. So OSPF was been configured. Now going to the question again, it's saying perform port security where the account server is connected so that no other device can connect to it. So port security to this account server, so it's connected to FA0/5. That's the port I've used to connect to this server from the switch. So we are going to perform port security on this particular switch. Okay, so for this one, I'll go direct to the switch, then explain. So remember, I was saying we've connected the server to the interface, which is 0/5. So first off, we're going to say en, which is enable, to go from the user mode to the privileged mode. Then we are going to say conf, which is configure t, so configure terminal, to go from the privileged mode to the global configuration mode. So here we're going to target the interface for that switch. So I was saying interface, but it's FA Fast Ethernet 0/5, because that's the interface which I've used to connect that server to. So once we enter this interface, we're going to say switch port, then mode access. So we are creating this interface into an access port. After that, we are going to say switch port security, because we want to insert port security to this particular port. So Under port security, we can either say maximum. So for maximum, it allows you to put the number of ports or devices which can be allowed to access that particular port. So in this case, we just want the server. So say maximum. So the maximum, since we just want the server, I will limit it to 1 because we just have a server. So after doing that, we are going to enter. Now again, we come back to the switch port security. Now we are going to insert a MAC address which needs to only access that particular port. In this case, it's the MAC address for the server. So say MAC address. Now the MAC address, you can either assign it automatically by using sticky, or you can just put it manually by using this first option. So in this case, since it's a small network, I'll just do it manually. So I just need to know the MAC address for this server. I'll click on the server, then under command prompt, I'll say ipconfig/o to check all information about this particular server. So my target is the MAC address. So the MAC address is also known as the physical address. So that's the MAC address. So I'm going to copy this MAC address. And then after I copy, I'm going back to the switch. So now we are going to paste that particular MAC address. Okay, so we are going to click enter. Now that we are done, I can end, then save the configuration by WR. Then we're going to say show port security to check if port security is there. So or we can say show port security, then we specify the interface, which is FA 0/5. So our port security is disabled. So just a minute, we haven't enabled port security yet. So let me just check again where we went wrong. So we are using the interface, which is FA 0/5. Okay, switch port mode, then access, then switch port security. Okay, so here we had to say port security. Okay, and then after selecting port security, now we had to put the maximum. So in this case, the maximum, we just said 1 because we just need the server. Then after that, we are going to go back to switch port. Then we assign the MAC address we want. So the MAC address, we just assigned it manually. And then okay, so duplicate found, so it means port security was enabled. So let me end, save the configurations, and then show port security. So as you can see, port security is up, and the maximum number of ports which can devices which can connect is 1, which is just the server. Then the current MAC address is recorded 1 for the server. So the violation, we haven't put any, but so it will be under shutdown. So you can either protect, restrict, or shut down the port. So in this case, we are going to shut down the port. So to check more information, you can just say show port security, then you specify the interface, which is FA 0/5. Then you're going to see that okay, port security is enabled. Then the violation mode is shut down, meaning Whenever we connect another device to that port with a different MAC address, the port will automatically shut down. So we are good to go. So let's see what port security does. So since this is FA 0/5 for the server, I'm going to get rid of that particular port. Then let me see if I try to use that port for the other device. We see what will happen for that particular interface with port security. So it's this port 0/5. So if we go back to the switch, we are going to realize that now once it initializes, we'll be checking the information from here. This port must be switched off or shut down because it's not allowed to be accessed by other devices apart from the server. That's the meaning for port security. So we are going to give it some time, then we see what's going to happen. Okay, so we can see that okay, this port has connected, but we want to make sure that this port is shut down whenever we connect it to another device with a different MAC address apart from this device. So for us to confirm that, since this device was used to see if we can communicate with other devices on a network. So if port security is implemented, this device won't be able to communicate with other devices such as this one or the other ones because it's not allowed to access that particular port. Hence, once we try to communicate with another device on a network, that port to be shut off, meaning it has security, which is port security. So let's confirm. So as you can see, now the port has been shutted off. So that's the meaning for violation mode, which is shut down. So if we but now if we take it back to the rightful device, which is the server, we are going to realize that if we try to ping another device, it won't really need to shut off if we take it back to the server. So we can see it had administrative shutdown. So now this interface is connected back to the server. So under the switch, I can just say conft, then go back to that interface which is 0/5, then say no shutdown, because for the server we need to make sure that it's up. Okay, so as you can see, everything is back to normal. So it means we are done with that question A 1 and 2. So we are done with this part. So this is Soko James representing KMU Cybersecurity Tutorials. Thanks for watching.